Good evening. This evening, I just want to explain to you extraction of aluminium. Like I always tell you that there are four uses or four applications of electrolysis. Number one, that electrolysis can be used to manufacture important compounds such as sodium hydroxide, hydrogen, chlorine, oxygen, and so on and so forth. And the second use of electrolysis is that it can be used to extract metals and also purify the metals. So here we're talking about extraction of metals. The last use of electrolysis um, is for the purpose of electroplating to protect a metal that is prone to rusting or corrosion by another metal that is corrosion resistant. We call that electroplating. So tonight I just want to discuss with you the extraction of metal. An example of that important metal is aluminum. Aluminum is one of the core metal that you must know in and out for your for success, for success to smile at you. Aluminum is extracted from it all. The ore is converted into pure aluminium oxide. The scope of the conversion is beyond this your syllabus, which is then undergoes electrolysis as shown below. So we have the diagram of electrolysis, the anode and the cathode, the electrolyte, and the wire and all of that. Now name an ore of aluminium. The ore of aluminium is bauxite. Bauxite is the ore of aluminium, whereby when aluminium is extracted, it is a profitable venture. And so is an ore that contains large proportion of aluminium. So what is meant by the term electrolysis? This is a two-mark questions, and the marks are divided into two by definition. Breakdown of electrolyte is 1 mark, but the passage of electric current is also 1 mark. So it must be fully defined. And in chemistry, we don't tell stories. We just write the point and then you score your mark. Telling story is a waste of time and space and energy. B, aluminum oxide has a melting point of about 2000 degrees Celsius, but the electrolysis process operates at about 900 degrees Celsius. Name the compound added to aluminum oxide to reduce the operating temperature. The compound is cryolite. Cryolite has a chemical formula of Na3Al-F6 trisodium aluminium hexafluoride. Na3Al-F6 trisodium aluminium hexafluoride. Cryolite is softer than bauxite. So the addition of cryolite to bauxite provide or gives or can we can deduce three usefulness of cryolite in the extraction of aluminum. So number one, the addition of cryolite is to serve as a solvent. It bauxite dissolve in cryolite, and so it serves as a solvent, and so it makes bauxite to dissolve more. Number two, when it dissolves more, bauxite cannot become a better conductor. All right, so in molten state, it's not, it won't be the thing the ions are separated, but not fully separated. But in bauxite, they are more dissociated, and so it's a better conductor of electricity. Therefore, the use of bauxite makes the use of cryolite makes bauxite it helps to increase the electrolytic conductivity of the process. The third one is that it reduces the operating temperature of the process. Because it has a lower melting point, the overall process has been reduced. And in fact, the fourth use is that as a result of the fact that the temperature of the process has been reduced, the the anode that is made of carbon normally react with oxygen produced at the anode. And so at a lower temperature, the amount of money wasted in replacing the anode has been reduced. So it reduces the cost of the process because the rate at which the carbon is replaced is also reduced because chemical reactions go at a faster rate at a higher temperature. Now that the temperature has been reduced from 2000 to 900, the operating cost has been reduced. So the addition of carbon that saves cost or saves the energy cost of the process. Therefore, let's go to B1 figure 2. So just one benefit of the environment of the reduction of the operating temperature. Like I just said, because the temperature has reduced, the rate at which the carbon anode is replaced will also be reduced. That's number one. Two, when the carbon anode reacts with oxygen, that is formed at the anode, it forms carbon dioxide. And carbon dioxide is a greenhouse gas. It increases the temperature of the environment. So if the process that leads to the production of more carbon dioxide has been reduced, the environment will have lesser amount of carbon dioxide, which automatically will reduce the carbon dioxide emitted to the atmosphere. So it reduces the carbon dioxide emitted to the environment. Over figure 3, write the ionic equation for the reaction taking place at the electrode. The first one is the negative electrode. The negative electrode, we attract the positive ion. And the positive ion of interest in this process is aluminium 3 plus. So aluminium 3 plus, at the cathode we have reduction. So aluminium 3 plus will accept 3 moles of electron to form aluminum solid at the cathode. The mass of the cathode will increase because aluminum is deposited at the cathode. Then the positive electrode is the anode. Because we are dealing with a molten process, we have oxide ion. An oxide ion will react to form oxygen gas and 4 moles of electron. We need to balance the equation by putting 2 moles of oxygen somewhere around this place because 2O, 2O times 2, that's 4. So 2 moles of oxygen will come in there so that we can have a balanced equation. And then moving forward from here, we explain why the anode need frequent replacement. The anode normally reacts with oxygen at that temperature 900 degrees. The anode will react with oxygen and burst into flame. And therefore, in order to sustain the continuous production of aluminium, the anode has to be replaced regularly. The anode reacts with oxygen to form carbon dioxide. Always check the mark. So there are 2 marks there. The anode reacts with oxygen or bonds with oxygen is 1 mark. To form carbon dioxide is another mark. That we must be careful to give our answer. Now let's move to the C part of the question. Aluminium oxide reacts with acids and alkalis. What term is used to describe an oxide that reacts with acid and with alkalis? Of course, that is an amphoteric amphoterism. What term is used to describe an oxide that reacts with acid? That is an amphoteric oxide. Okay, and the process is amphoterism. Also, amphoterism is a phenomenon that describes the process whereby an amphoteric oxide will react both with an acid and alkali to form salt and water. So, aluminium oxide reacts with dilute sulfuric acid to form a salt. State the name of the and write the formula of the salt. Since it is reacting with sulfuric acid, aluminum will form aluminium sulfate and Al2 bracket SO4 3. So we're going to have something 3 added to this place. So we have 3 here, or simply Al2SO4 bracket 3. That's 2 marks there. The name 1 mark, the formula 1 mark. Mark figure 3. Aluminium oxide reacts with dilute sodium hydroxide to form a salt and one other product as water, and the salt is a complex salt. Sodium dioxoaluminate 3. That's a complex salt and water, and so that's why you are not asked to name that salt, because the complex salt, the scope for naming that salt is not it's not within the scope of this topic we are teaching right now. In your sixth form college, we learn how to name that, but the complex salt, sodium dioxoaluminate 3. Figure 4. Aluminium hydroxide decomposes when heated to form aluminium oxide and water. Write the chemical equation for that. So aluminum hydroxide is that, and then Al2O3 plus 3H2, just a balanced equation, and we are good to go. That's all. Make sure you write the equation. The formula of aluminium hydroxide. Aluminum is plus 3, OH is minus 1. So it's AlOH bracket 3 to give us Al2O3, then 3 moles of water. Then figure 4. Select the name of 2 other aluminum compounds that decompose when heated to form aluminum oxide. Of course, aluminum nitrate will give you aluminum oxide, NO2 and O2. Aluminum carbonate will give you aluminum oxide and then carbon dioxide. That's all. Don't use other ones that can give you headache. These 2 are very good. This is how we're going to stop on this topic for now. I hope I can have enough time to do more, and indeed I should give you more, especially planning, and that will come tomorrow. But for now, I wish you all the best. Thank you.